Welcome, everyone. We have a final session here of the day before we can all go to dinner. So without further ado, I'd like to welcome Anders from Joby Aviation. And then later on, we'll have a couple folks from Everstream and EY doing a fireside chat. So Anders, take us away, and I'll be here to intro the Eversource and EY team.
All right. Can everyone hear me? All right. So sorry for the bait and switch with the title of this talk. For our purposes, AI is going to mean aerospace intelligence. And then I'll let the next people talk about artificial intelligence, if y'all agree. So I'm going to talk about how we use Databricks to scale our flight safety, our flight testing operations, and run them fast and safely. In case you missed the massive airplane downstairs in the expo hall, Joby Aviation is building an electric air taxi for passenger service. And we're currently moving through the fourth of 5 stages of FAA certification, which means we're running a whole bunch of test flights across our fleet of 6 test vehicles. And so pictured up there, you can see our first inhabited piloted flight. That was a few months ago. And so not only do we have a bunch of aircraft that we're testing them a bit all over around the world. So here in California, where our main operations are based, New York, Japan, South Korea, and most recently, Dubai in the Emirates. Wow. And so all of these tests produce a whole lot of data, which is where Databricks comes in. So we've been using Databricks to support our flight test operations for the past 6 years. We were a pretty early adopter of the platform. And I think by my last count, we have about 1,000 engineers using Databricks in some shape or form. And so everything that happens on our aircraft gets hovered up into Databricks. And that's about 18 billion rows a day, or 2.5 terabytes per day, probably more now. These numbers are pretty old. And so that's a whole lot of data that you need to review every time we do a test mission. There's an incredible amount of engineering that goes into an aircraft from so many different disciplines. So every time we run a test flight, we have engineers, like you have your battery engineers, your structural engineers, controls engineers. I think we now have like 15 different disciplines that are tapped for each flight review that need to check literally hundreds of conditions every time we fly to make sure things are safe and we can continue pushing the envelope on our flights, literally. And this needs to happen fast, because we can't run the next test flight until we've reviewed the data from the previous one and made sure everything is safe. And so this is really, really tedious work that takes up hours every day from our most talented engineers. And we'd like to free up these engineers to be able to do actual development work instead of clicking through hundreds of plots to make sure they all look good. So how do we automate this? Well, ideally, we'd like to be able to take all of these plots, and instead of clicking through hundreds of plots, you get a nice little checklist that tells you if each aircraft subsystem performed as expected. And then maybe instead of needing to tap your controls engineer for every single flight, you only need to ask them to take a look at the raw data if our automation flags something as wrong. So how do you coalesce these hundreds and hundreds of very disparate technical conditions into a neat report? You want to be able to build automated dashboards, Slack webhooks, all of these things to get the results in the hands of your engineers. But it's very hard to automate if your data isn't in the same shape, because you can't standardize anything. So kind of the first thing we took a look at is we talked to our engineers and kind of try and extract some trends from the things they're interested in looking at. And it turns out there are only maybe 2 or 3 really big categories of things that engineers check when they look at the plot of a physical signal. Maybe they're checking that it falls into just a predicted range. So maybe I know that my propellers should only spin this fast and not faster. Maybe I have a range where it's safe to operate, but it's OK if I exceed it briefly. So I look at some sliding window and check that my propellers weren't spinning faster than my limit for, say, more than a second. Or maybe I just look at a sample statistic and say, I just care that the 99th percentile of packets on my aircraft network aren't late. So once you've kind of done the work of talking to the engineers, you can come up with 2 or 3 standard schemas that capture the conditions that people are interested in delta tables and build your automated reporting. And so if you've been paying attention, these all look like very simple Spark or SQL operations. But there's another problem, which is all of these engineers, so our controls engineers, batteries engineers, and so forth, they aren't familiar with Spark or even with SQL. And so we don't, but they are the ones who are ultimately familiar with how our aircraft should operate. And these are the people we want maintaining and defining the conditions that let us check whether it's safe to fly. And so kind of to meet them where they are, we've come up with this DSL where an engineer can specify a data source, maybe some simple transformations and filters, and a condition to check. So here we're checking, say, that the voltage falls within an expected range without writing any Spark code. And so this kind of breaks the boundary between our domain experts and us data engineers, where by building a platform, we kind of get out of the way and let the engineers self-serve new checks without needing to know Spark. A kind of pretty key point here is that this all happens in Databricks. And so engineers can very easily spin up a notebook and run these checks against these terabytes or petabytes of data to make sure that they capture the conditions they want before putting them into production. And that would be like very, very difficult to do if you didn't have a platform like Databricks, where this just happens in a very turnkey way. So now you've gotten your engineers to define hundreds or thousands of conditions. How do you run these at scale? Because remember, this is only useful if you can get the report out fast. Because if it takes several hours, engineers aren't going to wait on the automation to run. They're just going to go look at the raw plots, so they can get on with the next flight. So luckily, Databricks has some pretty powerful primitives for running things in parallel. The first one is workflows. So there you can see kind of a fictionalized version of the DAG we run in production with Lakeflow jobs. And it lets you define dozens tasks that run in parallel. And a key thing here is auto-scaling, because your input data ranges and the conditions you want to check are so variable that there's no way to know ahead of time how big your cluster needs to be. So this kind of auto-scaling lets us ignore all of these problems and just say, hey, run all of these conditions and figure out how many nodes we need. But that still doesn't get you all the way here. Workflows are limited to, I think, 100 tasks, and we want to check hundreds, if not thousands, of conditions. So how do you do that efficiently? Well, you could create more workflows, but each task in Databricks is actually pretty expensive on the driver. It costs about 500 megabytes of RAM just to spin up an empty Spark session. And so if you multiply that by 1,000, you end up needing terabytes of driver RAM just to submit your tasks. And that would be comically expensive at the scale where we're running this. So the way you solve this is each task in this previous DAG runs a thread pool. And that thread pool takes 50 or 80 of these checks and submits them in parallel to the cluster. And so that's how you can run thousands of things in parallel in Databricks. Now, there's still one thing I haven't talked about. So if you follow the math here, we have thousands of checks. We're running multiple copies of them simultaneously, potentially for multiple aircraft. So you actually have thousands or even tens of thousands of concurrent writers into the same tables. And so to support this level of concurrency, you actually have to be pretty careful about your data architecture and come up with a way of laying out your data that supports this level of concurrency. And so what we ended up with is what you'd call a log-oriented data architecture, where all of your tables are treated as immutable logs, where you can only ever append data and never update an existing record. And so why is this useful? In Delta, merges can conflict and fail. Say if you're writing to the same partition, you can end up with a concurrent merge exception or all sorts of nastiness that could cause you to fail or invalidate your data somehow. Whereas when you append in Delta Lake, you can pretty much scale infinitely and run as many parallel appends as you want without ever running into a problem. This still leaves one issue. For most practical workloads, you need to be able to update existing data. Say there's a check, and I need to rerun it because we tweaked the thresholds. So, but how do you do that when you have an append-only data structure? Well, you can kind of work around that and simulate an upsert by using a view. So say you define a unique identifier in your log for each condition you want to check, and then you stamp every row with a timestamp at which it was produced. Then I create a view, and that view for each unique ID, or for each check, will take the most recent record for that check. And what happens effectively is an append to the original table ends up updating the rows for that ID in the derived table. And so that way you can kind of recover a concept of updating a record without ever doing a merge into in Delta. A kind of key thing that makes this possible is liquid clustering, because when you're partitioning on write, you might end up with imbalanced buckets, and then your queries can be pretty slow. Whereas liquid clustering, it does the optimization on write, so you don't have to worry about your query performance downstream. And then you get to also have your cake and eat it too in terms of supporting all of the analytical queries that people are interested in. So for instance, you might be interested in slicing the data both by something high cardinality, like time, and low cardinality, like the ID of a flight. And without liquid clustering, you're left with kind of a sea of tough decisions where you have to sacrifice the speed of one type of query to support the others. OK, so what impact does this have kind of overall for test operations? Well, it means we're able to check 700 conditions. I think it's probably more now because we're adding some every week, automatically every flight. And this happens in under 30 minutes after the data lands in Databricks, which lets us meet pretty tight deadlines. People almost don't need to wait on the data review before they can give the OK for the next flight. And overall, after talking to our engineers, this makes them about 5 times as fast at doing their job. Whereas before, for every single flight, every mission, you'd take maybe half an hour to dig through all the plots. Now you just open a neat little report and maybe look at one plot if the report flagged something as wrong. So yeah, it lets us go both fast and safe, because we get to check all of these safety critical conditions consistently without any human error and fast. And so yeah, I think it adds up to hundreds of engineer hours saved every month as we scale up flight test. And I've got 2 minutes left for questions.
Hi. I work at a robotics company, and I'm solving very similar problems. So I was super excited to hear your talk. I am curious, the telemetry must be super fast and tons of data coming in. What's the ingestion architecture like into Databricks? Is there anything in between, or are you just doing straight streaming into it?
It's pretty complicated. You could honestly spend 2 hours talking about it, but it's a mix of all of the processing actually happens in AWS first, where we upload the recordings, and then they get streamed through queues and structured streaming into Databricks.
Okay, cool. Thanks.
Anyone else? All right.
Hey there. Maybe I missed a point, but is there still human in the loop? Because
yeah.
Yeah.
So, well, first of all, not all of the conditions we want to check are fully automated. And so sometimes they're really just our engineers who need to look at the plot and be like, OK, this data looks right based on what I know about batteries or control theory. And then the other part is this automation kind of it doesn't give you an absolute it's safe to fly. It'll flag something that it thinks is wrong. And then it's kind of up to the engineers at the end of the day to, once we think it's wrong, they go and dig into the raw data and make the call as, is this something that should block flight test, or is it just something that's expected to fail sometimes, but I should know every time it fails.
Okay, thank you.
All right.
Excellent. Thank you, Anders.
Thank you.
That was wonderful.
Here we go.
Now I'd like to welcome up our folks, friends from EY and Eversource Energy to take us through a fireside chat. So welcome Shnimar and Zaki.
I've had the privilege of knowing and working with Snimmer for a couple of years now, and she's a phenomenal leader. She's someone who stood up her organization and formed a team and drew out a vision and delivering on that vision. So I've had the privilege of working with her and knowing her. So we wanted to take this opportunity here of understanding the Databricks-centric journey in a power and utility. So if you think about the data that she's managing and the data her team is responsible for, at the end of the day is translated into how well the lights are kept on, right? So again, thank you, Snimmer. Appreciate you doing this. So let's start off by talking through your journey, right? Your journey as a data leader and how you've come about to kind of draw this Databricks vision in your company.
Yeah, absolutely. I'm hoping this thing works. It's a little flimsy, but let me start with introducing Eversource Energy because that's the company I work for. So we're a large utility company in the Northeast. We're serving Massachusetts, Connecticut, and New Hampshire. We've got about 4.4 million customers, just to kind of give you a scale of the area that we serve. And we're over 10,000 employees, so we've got a lot of operations and a lot of data that's generated. And utility is almost like an underdog. You don't think about innovation when you think utility. But it's a super exciting time to be in the utility industry. There's so much innovation going on. Our friends right before this one, we're using drones and we're using those capabilities to get ahead of some of the challenges that we've had as a very traditional company, where instead of rolling out a truck to find a place to fix our infrastructure, which is an aging infrastructure, we're trying to use this fantastic technology that we have at our hands and trying to build that inflection point where we have all these cool innovations that are going on, and here we have an aging infrastructure, and what is that mesh? So it's a super exciting time. What I'm trying to say is the utility industry is running leaps and bounds into this very innovative space where we're starting to leverage technology and absolutely thinking about data and using AI and the capabilities there. And you asked me about my journey as a data leader. So I started very many years ago, and I won't tell you how long ago, developing in C++ and SQL. My friend here, who's sitting right in the front, we started our careers managing a data warehouse in Hyperion reporting. I'm laughing because those are words from the past, but those were our reality. That's how we grew up. So very much entrenched in data. And my background as such is in business, but we opened all of these opportunities within our own careers. You move to different places. So I just ended up in data, and I've been in the data space for about 2 decades now. So it's absolutely thrilled to be here because Databricks is a partner with us. We are building up an enterprise data team and a data platform powered by Databricks. As you can imagine, we've got fragmented business spaces that have a huge need for data, but no cohesive data strategy that brings all of that data together. So we're working with very capable partners like EY to help us set up that infrastructure powered by Databricks.
And if you think about utilities have so much of data, especially data coming in from all of the assets on the ground, assets spread across both transmission, distribution, generation, what you may. And the asset information sometimes is aging, and a lot of manual inspection takes place. A lot of telemetry data is sent through. A lot of sensor data is collected. And all of the data coming in, of course, siloed. So how are you realizing the value of your vision through Databricks?
Yeah, that's a great question and a very relevant one because my company particularly, we're going through a digital transformation. So think about the meters in your house. Today, in many areas, there's a truck that rolls, that goes in your neighborhood and tries to capture the meter usage. And we're trying to move away from that and trying to bring technology and data to your houses. So we're replacing these old meters with these advanced AMI meters, we call them advanced meters. And what that does is it generates a lot of data that then my team ingests, but with the ultimate goal of giving our consumers that data in your hands so you can make better choices. You can be more aware of what your usage is, and you can adjust your behavior. You can also expect what your bill is. And with that, we're giving you that power to make those decisions on a real-time basis. And then that's the customer side of things. Imagine the grid side of things where we've got this, we keep going back to the aging infrastructure, but then the need that AI has on power and utility companies and the generation that's lagging, and we're just trying to keep pace. And how do we get ahead of that grid? How do we get ahead on making sure that the pole that's aging, or if a tree is going to fall on that wire, how do we get ahead on that and use data and AI capabilities to be more predictive? So those are the two things that I'm super excited about, Zaki. And there's, again, a lot of work happening in the industry that I think we're trying to keep pace with, but also use the technology that's available. Like our partners just ahead of us have done so much. How do we leverage what exists to make our lives easier and to then ultimately give our consumers that information in your hands so you can make better choices?
Snimmer is also passionate about data quality and governance, and this is something that is so dear to her.
Mm-hmm. Yes. That he just wanted to start me off. As data user and data leaders, I think one of my pet peeves is when people tell me data quality is not my problem. Data quality is everyone's problem. You're a part of that infrastructure where being aware of how you leverage data to maybe build a dashboard, or maybe you're on the source side of the house where you're generating data. The impact that it has downstream, all the way to who consumes it, is a part of everyone's problem. And it's fascinating because you think about a utility company, you think about this very old school company, which sometimes is true, but I had the amazing opportunity at this summit today to meet with other leaders from other industries, and some that I thought are light years ahead of the industry that I'm in. It's fascinating that everyone's still talking about data governance, everyone is still talking about data quality, and now we're talking about AI governance, but guess what? It's all rooted in data governance. It's all rooted in the fundamentals that we all are a part of, and we need to be very crisp about how do we set the stage with those fundamentals and with those building blocks.
So Snimmer, through the course of your Databricks implementations, and now the Databricks is within the organization for a couple of years now, what are some of the critical lessons that you've learned along this journey?
The first one, Zaki, that definitely stands out is the need there's such an opportunity with folks wanting to leverage data to make better decisions. That's where it all starts. There is this absolute need for data, but how do you bring a company any company, and this is not just utility industry, it's across the board, my entire career as a data leader. How do you build that story on you need data, but don't do it for one use case. Think about what happens next, what's adjacent to it, what's beyond, and how do you bring that value in and help others either grow or leverage what you've already built so you're not duplicating. That's a problem that I continue to be plagued with, Zaki. And one of the fantastic ways that Databricks has helped us is just the open sourceness. We invite people in to do hackathons to help us build what AI use case they'd like to see. And it just generates so much interest in the work that we're doing as a data team, as the AI team that's starting to build off within the confines of a critical infrastructure. So security is a huge role to play in anything that we do. But that buy-in, that continues to be something that we're plagued with. And coming back to what you asked me, so the lessons learned with Databricks and the open sourceness with Databricks is just the usability that our partners have. We've got a whole spectrum. Databricks serves that entire spectrum. You can be advanced users. You can be very comfortable with writing SQL, or you don't have to be, but you just have to know where to look. So those capabilities. We're also an Azure shop, so understanding how usage works, how people are consuming our data. We've got a medallion architecture, so how do we manage our costs? So all of those lessons we're still learning. We're about 2 years into our standing up of our Databricks environment, so we're pretty nascent, but the opportunities present themselves at every corner, and those are pretty exciting as we head into the digital transformation that I was talking about and the customer transformation.
These are exciting times for being in a utility. There is so much talk around grid resiliency, about load forecasting, demand management, and the influx of so many extra energy devices like your batteries, your solar, all of the clean energy that is coming in onto the grid, and it adds a lot more of the unknown.
Right.
Especially within how you manage and how it was managed in the past. So how do you envision using AI to solve some of these problems, especially within the Databricks environment?
Yeah, and Zaki, please weigh in on some of these use cases because you're helping us build out a lot of this in the transformer space because we've got an aging infrastructure, as we have been talking about. But then there's these fantastic knowledge base capabilities that we're considering. We're a regulated industry, so we've got copious submissions that we do to the Department of Utilities, as an example. So trying to look back into 300-400-page report isn't the easiest or the most fun thing to do. We have a fantastic use case where we've generated this agent that you can write a prompt, et cetera. You know how that works. And it comes up with a response. And it comes up with this tag that provides you with reference on page 10, section 2. This is your response. Go ahead and take a look. So things like that are helping us kind of alleviate some of the concerns our business teams have in spending this amount of time and just ramping up capacity in order to answer some regulatory questions that we know and expect. The other area which is extremely fascinating to me as we enhance the customer data together is and this is probably pretty new and the entire team is kind of still coming together on that. How do we use intent, and maybe it's sentiment intent, maybe it's, as a customer, if you call in to us, how do we use the data that exists today to better serve you? So if you've called in and you've gone online already, I don't know that today, but how do I know what your intent is? Why are you calling me? Have you done this before? And what is the potential reason for your call? Things of which are, you might think pretty basic, but those are fragmented. We've grown through acquisition, so the data doesn't talk nice to each other. So those are sort of things and exciting opportunities that we're looking at, but very much internal looking. And then there's the wonderful digital meter space that we're now navigating or starting to navigate, and there's a ton of opportunity there. How do we help our users understand the usage? How do we understand if the grid is overloaded, or how do we understand if we need to have more of a battery location here or not? So those types of use cases are up and coming. But hackathons are definitely one of the ways that we've kind of looked at these use cases that come to our desks, but always looking for those opportunities with partners like yourself and also Databricks.
Yeah, some of the use cases that Eversource has really worked on and has made tremendous progress has been in the transformation. If you look at the transmission area, the biggest challenge is how do you predict outages before they happen? In the distribution space, rather. How do you predict outages before they happen? So having looked at the enormous amounts of data that has been collected over a number of years on especially your momentaries. Momentaries are those outages that last less than 1 or 5 minutes. And now trying to understand all of the factors that led to that momentary, kind of getting that intelligence and viewing that with the external data sources like weather, for example, topography, and many other sources has given the intelligence for the algorithms and the AI to now predict outages before they've happened. So in one of our POCs, we were able to save about outages to potentially 96,000 customers.
Yeah.
So that's an enormous amount of savings that if you can translate into real dollars. So, and the positive effect that it actually takes on the customer, because you're now moving away from unplanned work to more planned interventions.
Yeah.
You're now moving away from having a lot of unplanned spend to more of a planned spend. So that is significant cost savings. So AI is kind of in the right and center of everything that is happening today, especially in terms of managing the grid, in terms of demand forecasting, in terms of how do you deal with the aftermath of a storm? How do you deal with the assets? How do you go into the predictive maintenance of these assets? The asset classes that are so distributed in the field and changed by the topography of the territory that they function in. So a lot of promise, and Databricks is very central to the vision.
Yep.
And especially listening from this morning's keynote, I think there's a lot of promise ahead, which certainly we'll have to go back and kind of draw that vision out of how not only is data being central to what we are going to think about, but also kind of build the intelligence on top of it to make it happen. So with this, we probably will take a pause and see if you have any questions.